Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today we're going to talk about comets, and in particular, Comet C 2021 S3 Pan-STARRS, pictured here from, I guess, just last night or early this morning as it's wandering around in the Cepheus constellation. So we're going to talk about how to capture the image and then how to process it in PixInsight and Photoshop. So first of all, let's talk about how I go about capturing the comet images, because there's a couple different ways to approach it. And one of the things I noticed looking at the data from last night as well as the night before last, now the orientation is different here, but if you look at this little swirl over here, that's the Propeller Nebula. And it looked to me like it was getting closer to the Propeller Nebula. And so this was 2 nights ago. This is last night, so this is rotated 90 degrees. Here's the Propeller Nebula, and you can see, in fact, it is getting closer. And if I overlay those two images, this is 2 nights ago, this is last night. So I would project that tonight it's probably going to be somewhere in here, right alongside the Propeller Nebula, with the tail going back towards the propeller. So I want to try to capture that field of view tonight. So there's a couple different ways to set it up, and you may be aware, you may not be aware, but we operate a remote observatory here in southwest Utah. And so I do all of my data acquisition from the remote observatory. Now I like to use Voyager. It has worked real well for me. A lot of people prefer Nina. That's fine too. You use whatever you're comfortable with. But using Voyager, it has this tool called the Voyager Web Dashboard. And one of the features in it is this virtual field of view that you can put in the target you're looking for. You do generally have to use catalog numbers. It doesn't do very well with names. Like it wouldn't do well with, Orion, for instance. You'd have to put in M42 or something. So here's the Propeller Nebula, and the red outline is showing the field of view of my Takahashi FSQ-106 with the ASI 6200 MC Pro, which is a color camera. And I can move this field of view around to position everything the way I think I'd like it positioned. So just for reference, here's this bright part of the nebula up here. Here's the Propeller Nebula, and we've got some bright stars here. Let's compare that to the field of view. So here's the Propeller Nebula, the 3 stars here correlate to the 3 stars here. So I would project the comet's going to be out here, maybe draw a straight line from those 2 of the 3 bright stars. So there's the bright stars, so it's probably going to be out in here somewhere, so maybe I want to move it down a little bit, do a field of view, something like that. I can also change the rotation angle with the slider over here, although I think that's probably a pretty good rotation angle. I like the way this nebula kind of cuts through the image at an angle. This puts the Propeller Nebula at a 1/3 in, 1/3 in, which is considered kind of a composition PowerPoint. It's not a rule you have to follow, but images sometimes work well if things are located using that rule of thirds rather than centered. And that will put the comet somewhere centered with the tail extending back this way. So if this is the field of view I want, I can capture this using the RoboClip tool. And I'll just click on RoboClip, and it brings up the RoboClip tool, which is basically a database to record fields of view that you want to use. So I'll click this big green box that says Get Data from Virtual Field of View. And now I'll come down here and give this a name. So this is going to be Comet S3 pan stars, and this is going to be 5:02 a.m. So I know it's going to be tomorrow morning, around 2 a.m., 3 a.m., somewhere in that time frame. And I'll just drop this into a singles group and click Save. And so now I've saved that field of view and the rotation angle. So I can close this. And now we're back looking at this is the remote computer up at the remote observatory. So we're looking at a remote desktop view of that computer's screen. This is the Voyager screen here. So what I want to do is now create a sequence for that field of view that I just created. So I can go to Tools, Sequence Editor, and this is where I would create a sequence. And it's usually easier to just start with one that you already have. So here's one from 429. So this has the luminosity and also with some data with the L enhance, which will give me a little bit richer detail of that nebula. And this is saved with the field of view from 429. So I just need to go into RoboClip and select the one we just created. So now it has the Comet S3 for 5:02 a.m. And I'll just save this sequence and change the date to 5:02. So now I have a sequence defined with a field of view for where the comet's going to be tomorrow morning. The other way I can do comets is one of the newer features in Voyager is it has a comets database. So I can create a dynamic target, and let me just quickly load. And this is what I've been doing the last few nights, is just using the dynamic comet. And to do that, you can see here I was just shooting luminosity frames. But if I click on comets, and if we put in, let's say, S3, so here's the 2021 S3 pan stars, so I can select that comet, click on Use This Object, and it loads that comet as a dynamic target. So whenever I pull up this sequence, it knows it's a dynamic target, and it will use the correct coordinates and center the target for wherever it happens to be on that day. So that way you don't have to go dig around and figure out where the comet's going to be. So that's a nice feature in Voyager. But because I want a particular field of view and orientation, I did it the other way. But the drawback of that is that sequence field of view is really only good for tonight. And so we're done with the sequence configuration. So let's just close this. We don't need to save that. Now the next thing I'll do is go into the drag script editor. And drag script is the tool that Voyager uses to kind of lay out what you want your imaging sequence to do each night. You basically use the same script night after night after night. So I just opened the one that I always use. And it has a bunch of startup stuff that you can mostly just boilerplate. And eventually it comes down here to block sequence 1. And within sequence 1, there's a step that says sequence, start immediately, end at 1 o'clock. And I think that's doing some RGB plus L enhanced data of the elephant trunk. So that'll run till about 1 o'clock, which is when the comet starts to come into position. So if I come down to sequence 2, this is where we want to put in the comet. So I'll just right-click on the sequence and choose Configuration, and it brings up this dialog where I can choose what sequence do I want to run here, and we want to run the one we just created. And I'm going to go ahead and let it run from 1 o'clock or whenever it gets there until the end of astronomical dark. So click OK. So now my sequence for the second half of the night is configured. All I have to do is save this drag script. And now I'm all set. And when I'm ready tonight, I'll just go to the drag script tool. I'll load the script into the drag script tool and then click on drag script run, and that will wait for astronomical dark. It'll connect to the equipment, do a focus, find the target. It'll run the first sequence until 1 o'clock, then it'll finish whatever frames it's on, and then go to the second target, find it, do plate solvings, get the orientation, focus, and then execute that sequence. So that's how I go about capturing the data. So let's talk about how we process the data. Once the data is collected, and I'm going to jump now into PixInsight, I process the data in PixInsight with the goal of creating these 3 images. This image is primarily for the background, and you can see the nebula back here. Here's that propeller nebula we were talking about. A second one is created from that same starting point of just the stars, and I do that with Star Exterminator to separate the stars from the background. So that gives me a stars image and a nebula image. And if you look at the nebula image, you can see the comet itself is kind of blurred across here because it was moving during this time, and even the tail, there's kind of a blur of the tail. The third image that I need is one of just the comet. And so here I've done a comet registration, and we have an image of just the comet. So how do we go about doing all of this? Well, you start in batch processing, weighted batch preprocessor, and this assumes that you've gone through and called out any bad subs if the wind caught the scope or focus was off or whatever. You want to throw those out. And I will typically start by just resetting WBPP so I can get a fresh start at it. This is as it was configured when I ran this a little bit earlier today. The tabs across the top are the various subs that you'll load. So there's a tab for bias, darks, flats, lights. There's a tab for calibration, one for post-calibration, and one for pipeline. So if we look at lights, these are all of the lights, and I just load those by using the plus lights button at the bottom, and that brings you to a dialog where you can select your light frames. And then you can do the same thing with the dark, bias, and flats. What I typically do is I will load an entire directory. So I'll click on plus directory and just navigate to where I have stored my calibration masters. And I have a folder for the Takahashi FSQ 106 with the one-shot color camera. And this folder contains all of the flats that I need, the darks, and the bias frames as master frames. So there's just one each. So I just select that folder, and PixInsight is smart enough that it can recognize from the naming and from the metadata whether it's a bias, a dark, or a flat. So it loads each one of those in the appropriate place. The last thing I need to do, since this is color data, is there's a couple settings we need to do on the calibration tab. First, we'll start with the flats. And if you notice the center column here, it will have settings available based on your selection over here. So if I click on one of the rows of flats, you'll see that it's changed the available settings over here. And the main thing I need to do is click CFA images to let it know these are color filter array or one-shot color images. And I want to apply it to both rows, so I would click apply to all flat frames, and it asks me to confirm that. And then I do the same thing with the lights. Click on CFA images, and with an Astro camera, it seems you usually have to specify the mosaic pattern. This camera is RGGB, and there's only one row, so I don't need to apply it to all light frames. But if I had luminosity and L-enhance and other types of lights, then I would have to click apply to all light frames. And I usually set a output pedestal of 300. And then the last thing is to come over to the bottom and choose an output directory. And you just click on the little folder here. It will bring up, again, a dialog where you can select what folder you want to store all of the working files in. In this case, I put them in the Comet C2021 5.1 AM, since this was from this morning. And again, you can see I've already run this, so it's already populated. So once it's all configured, you click Run, and it will do a quick check of available space, and then you either continue or cancel. I'm going to cancel since I've already run it. And now we'll pretend time has passed. This is finished running, and we're ready to do the processing. So I need to do two things. The first one is relatively easy, and let me just move these out of the way, and I'll show you how I created those. First, let's go to the output directory, and that's going to be in my swap files, Comet, master. And here's the master light. So this is the normal stacked resulting image after running the WBPP process. So they've been calibrated, stacked. If I do an auto stretch, we'll see, for one thing, it'll have usually a very nasty color cast. So there's a couple things I'd like to do to this. First, I'm going to pull up my screen transfer function tool and unlink the channels so I get a kind of an auto white balance image, and that lets me better see what's going on. I've had real good luck using gradient correction. This is the new gradient correction tool. There's not much gradient here, so I have been using a larger scale and higher smoothness, and even the simplified model, and then just click on the square, and it will run and remove any gradients. And it seems to improve contrast in the image overall, so I've generally been liking the results from this. It doesn't always do great, but usually it does pretty well. I have found you do need to refresh the screen transfer function to get a good view of what it's done. Sometimes it'll change quite a bit. So I'm going to say that's good enough. The next thing I'll do is run Blur Exterminator for correct only. So what I've done is I'm running Blur Exterminator, but I've checked the box correct only. And what that does is just go through and kind of tighten up the stars and correct any aberrations that might be there. Then I would do the spectrophotometric color calibration, and I have saved process icons for each one of my setups. So this is the spectrophotometric color calibration that has the Sony red, green, and blue color sensors already pre-selected. So I would run that on this image to get a proper color balance. And that usually runs pretty fast, so I'll just go ahead and run that. And when that's done, then we want to go to our screen transfer tool and make sure that we change it to do a linked stretch. Once we've already adjusted the red, green, and blue channels so that we have the proper white balance, then we want to preserve that correct white balance that SPCC came up with. So that's why after you do SPCC, you want to be sure to link the channels in the screen transfer tool. So it is done now. And you can see the appearance changed quite a bit. So now I'm going to click on the link in the screen transfer function and update that view. And this will show us now our color balanced view. The last two steps I would run Blur Exterminator again, and since these are fairly large stars, I would use a Blur Exterminator with a little bit more aggressive settings. And by aggressive, what I've done here is I've moved the sharpen stars from the default of 0.25 up to 0.35, and that just shrinks the stars a little bit more. Once that's done, then I would actually stretch this image, and I just use the screen transfer tool with a few modifications. Always update the view before you start tinkering with it, but you can, I'm just using the mouse scroll wheel and positioning this pointer in between the black and the midpoint slider to zoom in a little bit, and then I can grab these sliders, and if I want to brighten the highlights and darken the blacks, create a little bit more contrast here, I can do that. And then to actually apply this, you drag the triangle from the screen transfer function down to the histogram transformation tool, click the square, and that will apply that so that we've actually stretched the image. So now you'll notice the green stripe over here has gone away, so it's no longer indicating that we're looking at an auto-stretched image. If you're auto-stretching it, there's a little green stripe right here by the file name. So once you've stretched it, you want to make sure that you're not looking at an auto-stretched version of your stretched image. The last thing to do with this image would be to run Noise Exterminator and Star Exterminator, and that is what gives us this image of the stars and this image of just the nebula without the stars, but it really highlights how visible the smeared comet is here, and we'll have to fix that in Photoshop. The last step is to create the comet-only image, and to do that we have basically like 2-3 steps that we go through. The first, I'll just hide this down here for now. First we need to do our comet registration, and to do that I'll go to Process, Image Registration, Comet Alignment, and we just click on the Add Files, and we navigate to our swap folder, and what we want is the registered files. So there'll be calibrated, debayered, logs, master, and registered. And you want the registered files, and just click into the folder. There are all the registered subs. So we select all of those, and that adds all of these to the list of target frames. And you notice the first one has a pin and an arrow, and the last one also has that little pin. So double click on the first one and it will actually open that image. We can do a quick screen stretch, and what we want to do is zoom in to the comet and get right on the head of the comet and click once, and that puts a little bullseye on the head of the comet in this frame. Excuse me. Then go to the last one, do the same thing, screen stretch, zoom in, find the head of the comet, and click on that. So now we've told PixInsight where the comet is in registered files between the first frame and the last frame. And then it can interpolate in between based on the time the image was taken, so that it will line up all of the frames so that the comet is aligned, and the stars won't be, but the comet will be well aligned. And once you've done that, you just select an output directory, and I will typically just choose Comet Aligned, just create a new folder called Comet Aligned. And at this point, then you're ready to click the solid circle to execute this, and that will create all of the comet aligned images. I find I have the best success if I then remove the stars from all of those comet aligned images. Now, fortunately, Star Exterminator has a batch mode. So if I open up Star Exterminator, and I found using a large overlap, at least with my camera and my field of view, works best with these images. And then just click on Process Batch, and now we'll create an output file for the comet aligned and starless. So I'll create a new folder called Comet Aligned Starless and select that. And then you just click on the Select Input Files and Execute. And when I click on that, it brings up this dialog. And what we want to register, or what we want to remove the stars from, are the comet aligned. So we're going through all of these comet aligned images and creating comet aligned starless images. So we would select all of these and click Open. And so now it tells us it's ready to run. It's going to process these 29 files and create starless versions in our Comet Aligned Starless folder. And again, I've already done this, so I'm going to cancel. So now we have Comet Aligned images, and then we created Comet Aligned Starless images. And this was the set that we just created. So now we're ready to actually create our comet image out of the Comet Aligned Starless images. And to do that, we'll use image integration. So go to Process, Image Integration, and we add files. And in this case, what we're adding are the Comet Aligned Starless. Select all of those. And we're just averaging. Usually it uses the stars to calculate things like the point spread function signal weight. So I'm not sure it really helps to do that sort of scaling. So I would typically just do no normalization and no scaling. And then just click on the solid circle, and it will go off and execute, and it will create, if you click on the circle here like this, it will integrate these files and create the output image for you, which will look like this. Now the only difference here, this one has already been stretched, and I've run noise exterminator and blur exterminator and done a stretch, mostly focused on trying to make the comet look good. So once you have these three images, you save all of those as 16-bit TIFF images by just doing File, Save As, and select 16-bit TIFF. And once those are saved, we're ready to go to Photoshop. So in Photoshop, where we will start is by loading all three of those files into a stack. So go to File, Scripts, Load Files into Stack, and you'll get this dialog box that lets you browse for the files you want to load. And we want to go to our, these are saved, I saved these on the, right here in this folder. So there are the three that I just created earlier today, the luminosity stars, the luminosity without the stars, and the comet by itself. Click OK, and then OK again, and what Photoshop does is load those three files as layers into one document so that we can then start to combine these. So here's our background layer, there's our stars, and there's just the comet by itself. So let's start with the stars because that's the easiest one. I'm going to put each one of these into a group, and I do that by Control G to put the selected layer or layers into a group. Double click on the name and name it Stars. I'm going to pull it up to the top of the stack, and it's going to be in screen blending mode. And I know I'm going to add a levels adjustment layer and a hue saturation adjustment layer to manipulate the stars. So what the levels adjustment layer does is let you darken the stars, which makes them smaller. And of course hue saturation lets you add saturation. And I find usually as I add saturation to the stars, the red gets too intense. So I almost always desaturate the red by quite a bit. So that's the stars, and now we'll just turn that whole group off. Next is the comet by itself. I'm sorry, next is this nebula layer by itself. So Control G. This is our RGB background. And again, I know I'm going to drop a levels adjustment layer in here. What I want to do first is find an appropriate black point. Generally, I set the blackest point in the image to about RGB values of 19, 19, 19. And a way to find some of the darkest areas in the image to do that is to add a solid black layer. So I'm going to add a solid color layer, and it'll be solid black, and it's within this RGB group. And then I want to change its blending mode from normal to divide, and you'll see the screen goes white. But if I come down to this levels adjustment layer right below it, if I move the black slider in, you'll see as I'm making the darks blacker, I'm clipping more and more. And once it goes to solid black, so right here is what's actually the darkest or the blackest area on that image. But I don't know if I care about that area. I probably care more about the black area up here around this NGC 6914 or whatever it is. So what I'm going to do is zoom in here, and I'm going to grab the color sampler tool and go into where it's solid black and add a color sample. Now I can turn off that solid black layer, and we'll just quickly reset our levels layer. So now what I want to do is change the readout of that solid layer to RGB values of 19, 19, 19. And you can see right now there's the info palette, which you can get to here. If that doesn't show up, you may have to go to Window, Info in order to turn on the info palette. And it will show you some default settings, and yours may look different from mine. But then you can see the number 1 this is the sample that we just created, and it has a little number 1 on it. And there are 2 columns of numbers. There's 0, 35, 36, and then a slash, and then 0, 35, 36. What that's telling me is before adjusting, the values at that point are 0, 35, 36. The second set of values show what happens after you make adjustments with this levels adjustment layer that's currently selected. So what I want to do is raise this 0 to 19 and then lower this 35 and 36 also to 19. So that means this black area will be neutralized to a neutral, very dark gray of 19, 19, 19. So the way the histogram tool works, if I move this slider right under the histogram to the right, it will darken those values. If I move the slider down here on the lower scale, it will brighten. You can think of what this slider is showing is what's going to be the blackest black. So if I move it to the right, you can see it's making everything, all the blacks, lighter. Or I can make the whites darker. Normally you don't use this slider, you only use the ones up above. But in this case, because we need to raise the red value of 0 to 19, we will use this lower slider. So we need to target each one of the channels, and we do that with the RGB drop-down. So I'll choose red first. And what I want to do is move this slider to the right while watching this number until it gets to 19. So there we've raised the red channel so it has a minimum value of 19. Now I'll do the same thing with green, but in this case it's already higher than 19, so I need to darken it down to 19. And then we'll do the same thing with the blue channel and move it down to 19. And one thing you may, if you're having trouble getting it positioned with the slider, you can click inside the box and then use the cursor keys to increment or decrement that value to get 19, 19, 19. And you can see already we've greatly improved the color balance, at least to my eye on my monitor, and also the contrast. If I turn this layer off, that was before we made the adjustment, that's after. And now we know that we've got a nice neutral black point set here. And I'll usually just label this levels adjustment black point. And now I won't change this anymore. If I want to make any further adjustments to the levels, I would add another levels adjustment. And for instance, I might brighten the whites, maybe darken the midtones so that it's not too bright. And then I might even add some hue saturation and increase the saturation a little bit and get a nice dramatic backdrop. But I know nothing in here other than maybe over in this corner is going to be darker than that 19, 19, 19. But we do need to deal with this because we want to add a comet, and we've already got a kind of a blurry, messy comet. So to do that, I want to focus on just this layer. So I'm going to turn off these other layers, and I'm going to add a blank layer above it so I can do this non-destructively. And I'll label this healed comet. And what I'm going to use is the replace tool. If you click and hold on the healing brushes, you'll see there's a spot healing brush, a remove tool, and a healing brush. And those are the three I tend to use the most. The remove tool does a good job of matching the background that should be there. But I don't want to do this whole thing because if you look, the problem with most of this is it's just brighter than the surroundings, but you can still see all of the detail through it. So I don't want to change any of that underlying detail. Up here, we don't have any underlying detail. So from about here up, we just have to remove this and try to blend in something that looks appropriate. And so I've checked the sample all layers. And the only two layers that are visible is this blank layer I just created, which is currently selected, and the layer below it, which is the image that we're working on. But if I paint over this area with this remove tool, and then click the check mark to apply it, it will remove that and replace it with what it thinks probably ought to be there. And it looks to me like it did a pretty good job. Now this doesn't have to be perfect because we're going to be putting the sharp version of the comet over top of this anyway. We just want to remove the artifacts that show up underneath it. So now what I want to do is just play with the brightness and bring out the detail underneath. So I'm going to add another blank layer, and this layer I'm going to put in soft light blending mode because this is the blending mode that lets us selectively brighten and darken. I'll grab my brush tool, and I want about 10% opacity, which I can get to by just tapping the 1 key. I've got my default colors of black and white, and I can use the X key to just quickly switch back and forth if I need to. I can use the left and right bracket keys to make the brush bigger or smaller. And anywhere I paint with black, and we're painting at just 10% opacity, it will darken what's under there. So I'll start with a fairly large brush and darken this area. And what I'm trying to do is just darken this Something strange is happening here. Oh, it jumped from the brush tool. So I'm going to go to my history palette. So I need to go all the way back here to the blending change and make sure that I've got the brush tool. And 10% opacity, make my brush smaller, and let's try this again. So I'm just working my way along here, darkening the areas that look too bright, and blending them in with the surroundings. And if you go too far, like I just did, you can just tap the X key to switch to white and brighten it back up. I'm going to go to a 5% opacity, which I did by tapping 0.5, and try to blend this in a little more. And mostly what I want to do is darken, but I'm switching back to lighten if it looks like I went too far. What we're doing is just, this area was just too bright, and this lets us just bring back the darkness that was there and the detail that was visible through that blurred image of the comet. And it doesn't have to be perfect. You can check your progress by turning this layer on and off. So that's before and after. And that's probably pretty good. So this is before we did the comet removal, and this is having removed the comet. And so I probably need to turned off too much. So I think that's pretty good. We'll call that good enough. So now we have the background without the comet. And if you recall, this is our black layer and this is our levels adjustment. So now we want to add the comet on top of this. So to do that, I'm going to grab the comet layer, which has just been waiting for us patiently down here at the bottom. Control G to put it into a group. Change the name to Comet. And I'm going to drag this group up on top of the background group, but below the stars. Now the problem is there's a lot of other stuff showing through here, but what we want is just the comet. So fortunately, most of what's on this layer is darker than what's below it. And the comet is really the only thing that's lighter than what's below. So again, we can use our blending modes. If I change the blending mode of the comet to lighten, so now the vast majority of what was on this layer disappears and just the comet shows. Now there are a few things that show up, so we're going to use a mask to allow just the comet area to come through. And I'm going to do a little bit of a trick here. I'm going to add a layer mask to that group. So now the comet group has a layer mask that will affect everything within this group. And I'm going to again grab my brush tool and paint with black, and this time at 100% opacity. And by painting with black on this mask, you're going to see the comet just completely disappear, as I've just masked it out. So now I have a mask that hides the comet but lets everything else show. And what I really want is just the inverse of that. So making sure that it's the mask that's selected, and you can tell that by the little double outline around it, I can just invert this mask with Control I, and now it hides everything except the comet. So now we have the comet without a lot of fancy tools, superimposed where it belongs over top of the RGB background. And if we want to confirm that, we can turn off the two layers where we hid the comet, and you can see that it's pretty much where it ought to be, somewhere along that path. If we want to fine-tune it, we can always use the Move tool and position the comet so it's right in the middle, and then hide that. So that's the comet in its position over top of the background, and all we need to do now is add the stars back in. I tend to like not a lot of stars, so I'll turn the stars layer on, and if you like those stars, then basically you're done. If you want to minimize the stars a little bit, the technique I use is I'll target the stars layer and right-click to convert it to a smart object so that I can use a smart filter. Basically, all of this, everything I'm doing is non-destructive. I can undo anything that I've done so far. Now just go to Filter, Noise, Dust and Scratches, and the larger the pixel radius, the larger the stars it will remove. And I find usually somewhere in the 4 to 6 range does a pretty good job of removing the little tiny stars, but still retains the larger stars. And then you can fine-tune that with this levels adjustment. And let's say something like that. If we want to do some global adjustments, I would come down above the Comet layer and below the stars layer, and I might add a levels adjustment, a color balance, and a hue saturation. And these are now global adjustments that affect everything except the stars. So if we want to add a little bit more contrast, adjust the background, I will usually add one more layer here. I'll add another solid color layer, but this time I'll add a layer that's 19, 19, 19 red, green, and blue, which you can get to by typing 19, 19, 19 into red, green, and blue, or you can just type 13, 13, 13 into this hexadecimal field, like so, and that gives you 19, 19, 19. And then I'll set this to lighten blending mode, and that ensures that there's nothing in this image darker than 19, 19, 19. At this point, we've got a finished image. I would save this. I'll do a save as, and I'll save this in my 2024 photos. And I'm going to save this as a large document format, and this is Comet C21 S3 fan stars. And yes, this will be a large file. You can see the one I saved earlier is around 10 gigabytes. So yeah, they're large files, and they take up space on your hard drive quickly. So you have to manage space on your hard drive. The advantage, though, is everything is non-destructive. I can come back to this image and undo or change my mind on any step that I've made along the way. So I hope you found this useful. If you have any questions or comments, be sure to drop those in the comments below. And as always, I hope you have a great day today and an even better night tonight under clear, dark sky. Thanks.